Good morning class, my name is Medan Chia. Today I will introduce pre-lab experimentary electrochemical cell. As you know, electrochemical cell divided by two. There is volatile organic cell and electrolytic cell. Organic cell is a use spontaneous redox chemical reaction to produce electricity. Redox chemical reaction is a oxidation and reduction process. For electrolytic cell is using electricity to cause a non-spontaneous redox chemical reaction to occur, meaning that the reduction and oxidation cannot happen. So using electricity to cause a non-spontaneous redox reaction. For organic cell, the process changes from chemical energy to electrical energy. For electrolytic cell, the process changes from electrical energy to the chemical energy. For the sign of terminal, anode oxidation reaction with negative terminal, cathode is a reduction process with positive terminal. For electrolytic cell, anode and cathode will undergo same process but different sign of terminal. This is a set out of the organic cell. Anode is a zinc half cell and the cathode is a copper half cell. At anode, zinc will oxidize to form zinc 2 plus and 2 electron. The electron release will move from anode to cathode. At cathode, copper 2 plus ion will accept 2 electron to form copper solid. As you can see, the observation is a mass of a zinc electrode decrease and the mass of a copper electrode increase. This is a salt bridge. Salt bridge is a contain NaCl or KCl salt solution. So the function of salt bridge is to maintain the electrical neutrality and complete the circuit. For anode, zinc 2 plus enter the solution cause the excess of a positive charge. So the Cl minus ion from salt bridge will enter the anode. For copper cathode, copper 2 plus ion will remove from the solution, so cause the excess of a negative charge. So the K plus ion will enter the cathode to maintain the neutrality. Each electrode will undergo oxidation and reduction is depend to the value of the inert half cell for each electrode. Inert half cell more positive undergo reduction and inert half cell more negative is undergo oxidation. For copper 2 plus copper, the inert half cell is 0.34, which is more positive than inert half cell zinc 2 plus zinc. The experiment part A, zinc paired with copper half cell. Then the experiment is repeated by replace the zinc half cell with the magnesium half cell, aluminum half cell, and the iron half cell. This is a table we will record the result. So as you know, for standard reduction potential E0 cell, we will measure the condition at the standard condition 1 molar 1 atm. But for this experiment, we're using 0.1 molar, so it means that what we measure today is not E0 cell, it's an E cell, where it's referred to the Nernst equation. This is the result obtained from the different potential between the half cell of zinc 2 plus zinc and the copper 2 plus copper. So the result is E cell equals to positive 10 volt. Since the measurement using 0.1 molar, where is not the standard condition, so the result we obtain is a E cell, which is referred to Nernst equation, and the result is not referred to the E0 cell. So how we determine the inert half cell of the zinc 2 plus zinc? So we will start with the calculation with write the half cell for anode, cathode, and overall. We will calculate the value of the inert zinc 2 plus zinc by using the Nernst equation. So this is a Reynolds equation where the left side is a E shell equals to E naught shell minus 0.0592 n log product over reactant. The product is referred to zinc 2 plus and the reactant referred to CO2 plus. So that's why the importance of to solve this problem must include the overall equation first. The n is referred to the how many electron transfer in the redox, so the answer is a 2. So we substitute the value E cell equals to 1.10, N equals to 2, and concentration 0.01 for both. So we will calculate the E naught cell. So the E naught cell obtained is 1.10 volt, and we know E naught cell equals to E naught cathode minus E naught anode. So E naught cathode is referred to the copper, where we know the value is 0.34 volt. So E naught anode is referred to the zinc 2 plus over zinc, so where we do know the value. So at the end, the calculation E naught zinc 2 plus over zinc is a negative 0.76 volt. So the calculation will continue with a different set of experiment.